to show you guys how easy it is to create one. So I've got this up and running demo here. Typically, when you create a new recipe, you can create a standard recipe with one part, or there's dual feed, which is now multi-feeding, so you can create up to 4 parts in one recipe, or multi-model, which is up to 6 parts on the same platform. But we'll just stick with a standard 1-part recipe for demonstration purposes. So there's 7 steps here that you'll go through in the Eye Plus recipe wizard. And the first step is image acquisition. So this is going to light the backlight and run through 30 different images at different exposure levels that you can set. Right now it's set to 1 millisecond intervals, so from 1 millisecond to 30 milliseconds on the backlight. And if you have a front light, it'll also run through the front light at 30 exposure levels as well. This one right now is set to a 5 millisecond interval, so from 5 to 150 milliseconds. And that's just capturing images for us to go through and use for the rest of the recipe. So candidate detection is the first, I guess, layer of the vision filter that we're trying to pass these parts through. So I've gone ahead and sectioned off parts in a good orientation and a bad orientation. So these are all parts that I've set up in a orientation that we'll define as good. And then these are all parts that we've defined as bad, just for your reference moving forward. In this step, what we're trying to do is make sure that the vision can detect all of the parts on the platform and make sure that we've essentially identified all the parts here. It doesn't matter orientation right now, as we'll get through filter. We just want to make sure that we've got all the parts here. And so we can look at this view here, and all of the parts that Eye Plus is detected are in green. And if we look here at the segmentation view, we can kind of take a look at the black and white image that we see, and that will the vision system will use. And we can kind of see some noise up here, some noise down here. And so in the advanced options, we've got our segmentation method here. Essentially what this does is it looks at the pixels around all of the other pixels. So it'll go through and look at the difference between the surrounding pixels, and that's how it's going to determine a part. So if we increase this difference level here, it'll essentially increase that threshold that we're looking for and get rid of some of that noise here. And so sometimes if you've got a slotted platform or too high of an exposure level, you'll pick up some of the platform edges as a part. It'll define it as a green zone. And so we want to just make sure that we only have the parts on the platform. And we can create a noise filter here to remove any particles on the platform. We'll just go like 15 square millimeters here. And what that'll do is just remove any of small particles from being detected on the platform. So each step is going to have a results tab, so we can see essentially the results from the step. And at this part, you can create a part size filter. So this is the first filter step in the vision system. So as we see here, Eye Plus has automatically detected that these parts are smaller than most of the parts on the platform. And so it's going to filter those out by size. And so this step is really quick and creates a faster vision result. So if you can filter out a good amount of parts that are in a bad orientation by size, this is that first step here. The next step, step 3, is our AI algorithm. And so essentially what we're doing is creating an AI database and having all of the parts that are then detected in our production run through this algorithm here. Now we can kind of zoom in here and see that it might be a little bit difficult to detect differences here. And so you can select different acquisitions from those images that we took. So if 15 milliseconds works for us, we can continue to use this, and we recommend trying to use the same lighting settings throughout the recipe as is less images to use. Or you can use a different image. Say we wanted to up the exposure level and try and get some more part definition here and some more stuff from the backlight, we can. Otherwise, you can also use front light camera to get another image, and you can change exposure levels here. Kind of, it's hard for me to see at this angle, but do you think, what? I can't see it on my screen. Does that look like there's enough? Okay. So we'll just leave it at that and try it out. So the next part is essentially taking a bunch of pictures of parts on the platform, and we'll then sort them by good parts. So the way I typically do this is I set a bunch of parts on the platform in the good orientation and take an image. You need 50 parts to be able to run through the next step. So take an image, move the parts around on the platform so that we can get a broader range of parts and images. Then take another image, should be at 28 now. And then I'll flip them over into the bad orientation. And because we filtered out by size 2 of the orientations already, like on its side or vertical, we don't need to account for those in here because they're already removed from the last step. If they weren't filtered out by size, you would also need to account for those bad parts. So try and make sure that you cover all of your incorrect orientations in this as well, so that the AI can properly detect bad parts. So let's go through this. Sorry. Right. Take another image. So like I said, you need 50 to move on. However, if you would like, or it's a difficult part to tell with the lighting settings that you have, you can take more images and train the AI algorithm further. For now, we're just going to start classification, and it's essentially Tinder, but with parts. You swipe right for good and swipe left for bad. That was a good part. So the first 28 parts that we took pictures of were good parts. So I'm just going to move them all over into the good side. And this is typically how I like to train my I+ recipes, as it's easier to and quicker to just move through all the parts at once. So then 27 and 28. So now these are bad parts. So we're going to move them all into the bad candidates. The AI algorithm, this step, the candidate selection step, after 15 parts of each good and bad, it'll say, okay, enough candidates classified. It feels comfortable with making a classification, but you can always add more to boost the robustness of this step. So I'm just going to continue filling in all the parts, categorizing them. And so then we can apply classification, and it'll move to the results tab. And we can now see these parts that were previously in green from the last step have now been filtered out. And these are all good. And you can see the confidence level here. And so we see 96.2% is the lowest one, and then the next one is 5%. So I feel pretty confident moving forward with this. Obviously, if things are a little bit closer, you can train the classification a little bit further. Now we're going to move on to the pick point teaching step, where we're now teaching where we want to pick this part from. And like all the other steps, you can select a specific acquisition setting here if you would like. We're going to stick to 15 here. Yeah, just going to stick to 15. Right here, you have to put in the part's height. This is to account for parallax. So if you've got a taller part, something that has a little bit more extensive parallax, you want to make sure that this part height is as accurate as it can be, as I+ will account for parallax and place the pick point where the actual pick point should be. I don't know, these are probably 5-ish, maybe a little higher. And then the production plate height is filled in depending on your cube size. So 13 millimeters is standard for 240. If you create your own production plate and it's higher off of the platform, you can adjust this as you see fit. Yeah, so moving in, I+ is going to create this outline around the part here. And it's going to try and match this outline to every part that gets to this step, and match a pick point to it. And so we want to mask features that are either not on the plane of picking or are unimportant to us. So right here, we can probably mask out this right here. It's unimportant to us. This right here is also unimportant to us. Could probably even mask out some of this stuff here you'd like. Kind of just takes a little bit of practice to get used to what you need to mask out. So then you can mask this and it'll remove it from the outline. So if we go here, we've now not outlined any of the stuff that we've masked, and we can place a pick point. It'll automatically place this pick point in the center of mass. So where the center of all the pixels are, it's going to place. But we've got different geometry features here that we can use to center pick points as well. So we've got a square box that you can adjust here. We've got a circle as well that you can adjust as you see fit. And then we've got a perfectly horizontal and a perfectly vertical line. So we're just going to place it on the center of the circle here. I really cannot see that well, but I think perfect. So you can see it'll snap directly to the center of that circle there. And so if we go to the results tab next, we can verify results here and just check and see that everything's centered. So like I said, it's going to try and match those match that outline to all of these parts. And if it doesn't score high enough, it'll also get kicked out. So this is another filter step. This is really good for parts that are mirrored on one side. So say you've got like a bend like this, and you want to pick it only from this way. If it's flipped that way, the outline won't match, and so it'll kick it out. It's a really good use case. You can also adjust the score threshold here. So if you want to make it a tighter threshold or a little bit looser, you can. So yeah, that's that. Feel free to stop me in the middle of this if anybody has questions as well. Please interrupt or tell me if I'm moving too fast. So the next step is pick angle. So we want to define the angle at which we pick. So when I+ sends coordinates to the robot, it's going to give a rotation as well, and that's where the part is angled on the platform. And so we want to be able to define the angle that we want to send. And so this is where you would kind of set your robot's X, Y axis and rotation, and how you want to essentially center that. So we have the feature masking here as well. So we'll need to do the same thing. What's really nice is if we want to use that same outline that we have in the previous one, you can import the mask from Pickpoint Teaching. So if you hit import Pickpoint mask, it'll import everything and we'll have the same outline. It's typically what I do unless there's some certain feature that I want to be able to use to clock the pick angle. So if there's something on a top feature that you want to be able to mark as your pick angle, you could do a separate mask here. Yeah, I guess for this, we can try and line up this horizontal line right there and move, and it'll snap to that horizontal line there. You've also got this line tool too. So if you want to create a straight line somewhere, anywhere else, you've got that ability as well. Yeah, so I guess another advanced option to do, oh, it's not on here. You can pick apart from multiple angles. So if you've got, say you're picking washers up, and they're a circle, so you can pick it from anything. Or you have a part that's mirrored, you can have it repeat angles. Or if you don't care about the pick angle, you can skip this step entirely, and it'll just send the same RZ each time. So we'll just get rid of this. There is also an angular limitation here as well. So say you don't want to pick from a certain angle, say your robot can't rotate that far, or you want to make sure that parts can only be picked within a certain range, you can add an exclusion range here, and that'll filter out parts. Otherwise, it'll try and match that mask the same, and provide a confidence score here, and you can adjust that threshold as such. So here we can see that it's picking pretty well, clocking the angles and everything. So the step worked. The final vision step is setting your gripper drawings. And essentially what this is doing is creating an exclusion zone. So we've got circles for vacuum grippers and boxes for finger grippers. This one will use a finger gripper. You can adjust size, and it'll give you size in millimeters after you complete a vision calibration. So you can accurately size up your gripper however you want. I don't really know. We'll just go with like that. Sure. So then you can lock it on to the middle of where your pick point is and do that. And so this exclusion zone will designate this part as not pickable if there is another part detected within this range here. And so that's to avoid gripper collisions and robot collisions. So we'll just create another one right here. Again, can't see, so I don't know if these are matched up. They look good to me. You can also create picking limits and adjust picking limits here. So this is, again, for gripper collisions to avoid. If that gripper exclusion zone that we just defined in this step meets with this red box here, I'll bring this in because that'll show it. It'll designate it as not pickable either. So if we go to the results here, and you see this one is marked in red, it's because that gripper is overlapping the bounding box on the platform. And then the rest are highlighted in green. So yeah, well, you can adjust this as you see fit, depending on your application. Make it as tight as you want. And that's it for vision. You've now got a vision recipe set up. I+ will be able to detect and send part coordinates over. Super, super easy. I mean, we did it in 20 minutes. The last step is configuring your ASYcube. So the best way to do it is to adjust all of these values. So you can adjust the ASYcube vibration amplitude here. From 0 to 100%, you can adjust the frequency. The frequency range for the 240 is 40 hertz to, I believe that's 70 something. So you can adjust it as you see fit. It'll fill in default vibrations. And these typically work for most parts. And you can adjust the duration as well. And this is for smart centering and its capabilities. So when you adjust this duration here, it'll, this duration, I guess I should start by saying, the duration is from one side of the ASYcube to the other. And what smart centering does is it takes that center of mass on the platform and says, okay, we're this far from the center. And so I know how far or how long I need to vibrate for to get from one side to the next. So then linearly, I need to vibrate, say I was halfway, I need to vibrate half of that time to move it to the center. Does that make sense? Okay. And so you would go through and tune all of these features here. This is all of the different directions and a flip. And then these are our cross centering and long centering features. So if you want to move parts to the middle like that in a flat way or like that, that's what these two functions are for. You can also import vibrations as well from a previous recipe. So if there's parts that act or behave very similar on the ASYcube, you can import those vibrations directly from a different recipe and simplify this step as well. So I'll just do a quick test here. Maybe increase this to 70. It's down to 64. See how 2000 is, and we can test the vibration here. So when I hit test vibration, it'll move parts across the ASYcube. That seemed to work pretty well. You can also test the vibration continuously. And so when you do this, it'll turn on until you stop it. So yeah, you would go through each of these four here, tune them so that smart centering is as accurate as possible. We can tune our flip here. I'm just going to make sure that they don't fly out. Yeah, it seemed okay. Um, yeah, so essentially that's vibration tuning. You can always restore to default too if you need to. Next step is hopper tuning, and this is really useful for smart centering. So our new as you fill hoppers are analog output, and so you can directly control the amplitude here from I+. The smart feeding settings are optimal number of parts. So you put however many parts you think is the best on the platform. That'll take some time to get used to. Typically, it's around 1/3, or you can line up parts from corner to corner, and that typically can be a good indicator. It'll just take some feel to get used to.